So see now, next numerical is a charge of 8 microcoulomb is located at the origin. Calculate the work done in taking a small charge of 2 into 10 power minus 8 coulomb from the point A of 3 centimeter, 0, 0 to a point B of 0, 4 centimeter, 0 via a point 0, C, 3 centimeter, 4 centimeter, 0. Okay. So here, so in order to understand, I will write the diagram here. Here what they are saying, the charge of 8 microcoulomb is located at the origin. Okay, at the origin 8 microcoulomb is located. Okay, so calculate the work done in taking a small charge. So here they are taking the another charge, so 2 into 10 to the power of minus 8 coulomb from the point A to the point B through, so through the point C. Via means through the point C. This point C value is 3 centimeter, 4 centimeter, 0. Okay, so similarly point B value is so 0, 4 centimeter, 0, and point A value is so 3 centimeter, 0, 0. Okay, so this is the required given data. Okay, what they are saying, charge of 8 microcoulomb is located at the origin and a small charge of 2 into 10 power minus 8 coulomb is moving from the point A to the point B via point C. Okay, so I need to calculate the work done. So work done, I need to calculate what is the work done at the point A and work done at the point B. Okay, VA I need to calculate and VB I need to calculate and multiply it by the charge value. Finally, I need to multiply it by this charge value. Okay, so initially, so solution, what is the charge value they have given? Charge value is 8 millicoulomb. So that is 8 into milli means 10 to the power of minus 3 coulomb. Okay, so it's located at the origin. So now I need to calculate the potential VA, similarly VB. Okay, so that is what is VA? VA formula, potential due to the isolated point charge is given by the formula V is equal to 1 by 4 pi epsilon Q by R. 1 by 4 pi epsilon I have written as K. Okay, so that is K value is 1 by 4 pi epsilon. So if you simplify, you will get 9 into 10 to the power of 9 into Q value is 8 into 10 to the power of minus 3. So divided by R value. See, R value for the VA I need to take 3 centimeter and for VB I need to calculate by using the 4 centimeter. Okay, so what is the R value now? Via a point C means I need to take 3 centimeters. So 3 into centi means 10 to the power of minus 2 meter. Okay, so 8 9s are 72 into here, so 3, here 9, so 9 plus 1 plus 2 will become 11 into 10 to the power of minus 3. Okay, so if you simplify this one, you will get so 24 into 10 to the power of 8 volt. Okay, so this is VA value. Okay, so similarly VB if you calculate, you will get so same formula only. So K value 9 into 10 to the power of 9 into Q value is 8 into 10 to the power of minus 3 into R values I need to take now 4 into 10 to the power of minus 2. Again 8 9s are 72 into 10 to the power of how much you will get? So 9 minus 3, here 6, again so plus 2, minus 2 it will become plus 2. So divided by, so how much? 4. Okay, so if you divide this one, you will get 18 into 10 to the power of 8 volt. Okay, so this is VB. Now we got the potential at the A and the potential at B, but we need to calculate work done. So what is work done formula? So work done becomes so VA minus VB into charge. Okay, so what is VA value here? So VA value is so 24 into 10 to the power of 8 minus VB value is 80 into 10 to the power of 8 into multiplied by charge value. This value, this charge value we need to write. Okay, why? Because we are moving this charge. So that is 2 into 10 to the power of minus 8. Okay, so that is from the both these terms. So 10 to the power of 8 common, here 10 to the power of minus 8, both will get cancelled. So remaining is 24 minus 18 means, so we will get so 6. Okay, so work done here is how much you will get? So 6 into here 2, so W is equal to 12 joule. Okay, so this is the required solution.